Hey there, welcome back to this video where we are rewriting trigonometric expressions using known trigonometric identities. So in part one, we went ahead and looked at some of the examples and strategies about how to rewrite an expression, especially with a given destination. This video is going to focus on the multiple choice types of questions, and we have 4 types of options. So it's kind of really playing in a sandbox. Again, if you need to, please recap your known trigonometric identities. Here they are. You have the reciprocal identities, quotient identities, Pythagorean identities, and double angle identities. Okay, so let's go ahead and look at a practice question here. The function g is given by g of x equals tan x times sine x. Which of the following is an equivalent form of the function g? And notice that all of these options have a plus and minus in them. So that can kind of help guide you based upon where you need to go. So g of x, tan x and sine x, I'm going to go ahead, I'm just going to put everything in terms of sine and cosine, just to see kind of what will happen here, times sine of x. And notice that I get 2 sines of x's. So this is sine squared x over cosine of x. And what I'm going to do here is I'm going to substitute out this sine squared. So that is 1 minus cosine of x. 1 minus cosine of x. And it's not going to let me write. Cosine squared of x, there we go, okay. And here's where we're going to go ahead and change this structure. I have 1 minus cosine squared of x. I'm going to represent this as 1 minus cosine of x minus cosine squared of x divided by cosine of x. So I'm doing this because when I go ahead and I split this, I get that difference in change in structure here, okay? So now what I have, 1 over cosine, well, that is secant. And cosine squared minus cosine is just cosine. They cancel. Okay, so is this an option? Sure is, A. Okay, so again, strategies we use here, change everything to sine and cosine, use a Pythagorean identity for the powers of 2, and then you can split that monomial denominator. Okay, here is a practice question. The function h is given by h of x equals 1 plus cosine squared of x over sine squared of x. Which of the following is an equivalent form of the function h? Please pause me, go ahead, try this one, and I'll show you the solutions here in a moment. Okay, hopefully we went ahead and did this one. Since it's already kind of in a form where we have a monomial denominator, I'm going to split this. So we have 1 over sine squared of x plus cosine squared of x over sine squared of x. And 1 over sine squared of x, that is cosecant squared of x. Cosine over sine is cotangent, so we have cotangent squared of x. And looking at this, hey, I feel like we're getting kind of close, but my options don't have a cotangent in them. So here's what I'm going to do. I know that it's squared. This is probably involving the Pythagorean identity. Sine squared plus cosine squared of x equals 1. And to get cosecant and to get cotangent, they both actually have in common that the denominator is sine. So if I take these and I divide by sine squared of x, we can get an alternative version of the Pythagorean identities that we can use. This is 1 plus cotangent squared of x equals cosecant squared of x. So I really want to sub this out. I want to take out cotangent. So here's cotangent. I want that isolated. So this is cotangent squared of x equals cosecant squared of x minus 1. So we're just going to swap that out. So we get cosecant squared of x plus cosecant squared of x minus 1 gives us 2 cosecant squareds minus 1. And that is our answer, A. So hopefully you got A on that one. Okay. Another practice one here, this one involving cosine double angles. So if you need to, make sure you go back and kind of review those identities. But please pause me, try this one. F of theta equals cosine theta. 2 theta is equivalent to which of these? Okay, hopefully you went ahead and did that one. For A, this is equal to 1. So it's not A. We can eliminate that. And then D, this is actually the sine of 2 theta structure. This is the double angle formula for sine. So it's not that one. And then we have this one, B and C. Cosine of 2 theta, the one I like to remember is C. It looks very similar to the Pythagorean identity, except it's cosine squared minus sine squared of theta. So it is this one. And then to remember the alternative versions, the cosine kind of stays in its place and sine stays in its place. So the alternative versions that look like this are 2 cosine squared theta minus 1. So similar to B, but not quite it. And then the other one is 1 minus 2 sine squared theta. They all have subtraction, but the sine and the cosine kind of stay in their place. Answer is B. Or sorry, C. Answer C. Okay, next practice one. Please go ahead. I want you to pause and try this practice one here. Okay, hopefully you went ahead and paused and tried this one. G of x equals cosine theta times 1 plus tan squared theta. That 1 plus tan squared theta makes me think again of the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. And tangent has cosine on the bottom. So what if I went ahead and divided everything by cosine, 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 and what we end up getting is tan squared theta plus 1. Hey, isn't that what we have right here? And that is equivalent to secant squared theta. So we're going to go ahead and replace this with secant squared theta. So none of these, I mean, we're kind of close, but let's put everything in terms of sine and cosine to go ahead and see how this works out. So we get cosine theta times, this is 1 over cosine squared theta. And it looks like one of these is going to go ahead and cancel out. So we get 1 over cosine theta, which we know is secant theta. So answer A. Did you get it? Awesome. Hopefully you did. Okay, practice question. The function h is given by h of x equals 5 sine of 2x. Which of the following is equivalent for h of x? Please pause me. Again, this is another double angle one, so double check your double angle formula for sine. Should be a pretty easy one. Okay, hopefully you paused and tried this one. Sine of 2x is 2 sine x cosine x. So if we just go ahead and distribute that 5 to the 2, we get 10 sine x cosine x. That's going to be A. Multiplication is commutative. We can go ahead and swap those, okay? All right. Last one here, where both expressions are defined. Which of the following is equivalent to cosecant squared x minus 1 divided by cosecant squared of x? Okay, so please go ahead, pause this one, try this, and we'll show you the solution. Okay, hopefully you pause this one. This one is, again, what we're going to do is we're going to go ahead and split the denominator. Since I have a monomial denominator, we can go ahead and split this. Nothing kind of jumps out as like simplifying right away. So we get cosecant squared over cosecant squared minus 1 over cosecant squared x. This ends up getting us 1 minus, and then the reciprocal of cosecant squared is going to be sine squared of x. And this looks familiar, 1 minus sine squared of x. That's just a derivative of the Pythagorean identity, which is cosecant squared of x. So answer B. Okay, did this lesson make your head hurt? Hopefully it did. That is your brain forming new neural pathways, making you smarter, how you can substitute things out, work with what you're given, and get to a new location. So very, very good logical training. also working on your mental pathways with knowing what is equivalent, okay? Give this video a thumbs up if you learned something. I'll catch you in the next video. See ya.